Hi guys, for Calculus BC, this is 8.5 and it's called partial fractions. This is going to be a method that you're going to use when you see the integral of a fraction that has a pretty lengthy denominator, okay? So what you're going to be doing is you're going to be decomposing that denominator of the rational, which is a fraction function, into simpler, still fraction functions, rational functions, that can then be solved with basic integration rules that we already know. So when I explain all of this writing, this may seem a little confusing still, but I'm confident that when you start to see the examples, it'll start to make more sense. This section has a lot of algebra to it, okay? So here we go. The first step that you're gonna do when you catch that lengthy denominator is you're gonna factor it as far as it can go, okay? Then you're going to separate each of those different factors into separate fractions, okay? Now, you're factoring the denominator, and each in a different fraction, but the numerator, we're going to put variables of capital letters A, B, C, and so forth, okay? We're going to end up solving for those letters and then being able to, once they're factored, then solve each of them, okay, with our basic integration rules. Now, for each factor that gets left with an exponent, you have to write a separate fraction for each of those exponents. So let's say if this said x plus 3 to the third, we'd have to have one that says x plus 3 to the first, x plus 3 to the second, and then x plus 3 to the third. You need to do that for as many numbers that's in that exponent, okay? Another complication you might see is if you have an exponent inside the factor, okay? So for each factor that comes out, by the way, P here and Q represent numbers, okay? Coefficients and constants. So if I end up with a squared or any other exponent on the inside, we have to include a numerator that looks something like this. So my numerator should always have an exponent, a degree that is one less than the denominator. So notice if this is to the first, this doesn't have any variable. Same here, same here. Now notice this one is squared, so I have to include the variable x plus another variable, okay? These are two of like the higher level versions. They're usually a bit simpler than that, okay? So now once we have separated these fractions, our next step is going to be to solve for the variables a, b, and c, and so on, okay? You're going to multiply each term by the common denominator, okay? Then you're going to use algebraic methods to solve one variable at a time. Once you have solved for those variables, you're going to replace them in their solution. So step 4 is once we solve for a, b, and c, you're going to put them in those numerators. And then now I can integrate each of those individually. So again, all of this in writing may seem a little complicated. Let's go for an example so you can see how this works. For this first example, I see this on the test. I see a lengthy denominator, and that is my red flag to use partial fractions, okay? So step 1 is going to be to factor that denominator, okay? My denominator, right, I have x squared minus 5x plus 6. I can try an x and an x. Two numbers that multiply to give me 6 are either 1 and 6 and 2 and 3. If I want a value that's going to give me a negative 5, well, I can do a negative 2 and a negative 3. Okay? So now I'm going to rewrite this, and I'm going to say a over the first factor, and then plus b over the second factor. Okay, this is what I'm going to end up integrating. Okay, but first I need to be able to solve for a and b. So if I were to try and combine this back, because now I need to get this numerator to equal this numerator, right? If I wanted to combine these two fractions to get back to here, I would have to multiply by the common denominator. So this one would need to be multiplied top and bottom by an x minus 3, and this one would need to be multiplied top and bottom by an x minus 2. Back to algebra basics, okay? So if I say that the first one needs to be multiplied top and bottom by x minus 3, And the second one needs to be multiplied top and bottom by the x minus 2. So now if I'm working on solving for my a's and my b's, my numerator is going to read a times x minus 3 plus b times x minus 2, right? This is a times that and b times that. And now that numerator is what I'm going to set equal to the original numerator so that I can solve for a and b, okay? Now, one of the easiest methods to start solving for this, I said in the steps that you can use any algebraic method, is that I can try and cancel out one variable at a time. So if I can eliminate a, then I can solve for b, and then if I can eliminate b, I can solve for a. So if x is equal to 3, right? If I put a 3 in that spot, this is going to give me 0 and it'll cancel out a. I have a times 3 minus 3 plus b times 3 minus 2 equals 1. In this case, this cancels out. 3 minus 2 is 1, so I have that b equals 1. And I just solved my first one. Okay? Now, I can do the same thing by trying to cancel out b. If x was, well, if x is 2, it'll cancel this out. So I'm plugging that 2 into both x's. I already know what b is, so I could even, you don't have to write it because it's going to get canceled out, but if you needed to, because there were more variables, you could plug that b in, okay? So then I'm plugging in a 2. This is going to get canceled. And now 2 minus 3 is a negative 1. So I have negative 1 times a is negative a equals 1. So that means that a equals negative 1. Okay? So now that I've solved my a and my b, my next step is going to be to plug that in to their spots, right? Coming up here, I'm going to do the integral. If a is a negative 1, I can put the negative 1 up here up top, or I can bring the negative outside and put 1 over x minus 2. I'm going to close off that integral and write these separately. Plus the integral, b is 1, of 1 over x minus 3. Okay? And now from this big integral, now I have two simple, easy integrals that I know how to do. Okay? So if we treat this as a u sub, here my u is x minus 2, where my du, my u prime, would be 1. Okay, so this matches the integral of u prime over u. That's going to be an ln rule. Plus, and then here, if my u is x minus 3, my u prime, my derivative is 1, which is what I have. So I don't have anything missing, so I can just write the integral of u prime over u. So bring down that negative. The antiderivative is ln. Absolute value of u, instead of writing u, I'm going to go straight to writing what u is, x minus 2. If you don't feel confident doing that quick, write the u and then rewrite what u equals, okay? Plus ln, absolute value of u, this question's u, this integral's u, I'm sorry, is x minus 3. And then I have my plus c. So this is one option of your answers. In the AP test, they like to make you think back to your ln rules. And on a multiple choice question, if you have two ln's being subtracted, so here's the positive one and here's the one being subtracted, you can write that in division. Okay, so the ln rule, it would look something like this. So again, that rule is the positive ln goes in the numerator, the negative one goes in the denominator, and it is written as a single ln, okay? If you want a recap of these rules in my pre-calc videos, it's under chapter 3. And in calculus, I have them at the beginning of a chapter 5, derivatives, where we go over those rules before we went over the rest of the work, okay? Let's look on to this next question. So I told you in the last video that we were going to use that rule, the previous video's rule, when u sub didn't work. So the same thing goes for partial fractions. If I look at this question and I think, hey, maybe u sub will work, and I try, I could say u is x squared plus x minus 6. U prime would be 2x plus 1, which is close, but it is not what I have in that numerator, which means I cannot use this, okay? Don't be afraid to have a little trial and error in your math, okay? That you try something, didn't work out, and you're on to the next method. If that doesn't work, now I'm on to trying to factor. So not u sub. Now we're going to try and factor that denominator. So if I factor it, okay, I'm going to have an x times an x and two values that multiply to give me 6, but then add up to give me a positive 1. So I am going to end up with the same two numbers, but different signs. I'm going to have a 3 and a 2, and if I want my value to be positive, then my greater number has to be positive, okay? We add those together, and I'm going to put my variable a and b up top, okay? So same next step. We're going to multiply each by the common denominator. So I'm going to have a over x plus 3. This one's going to need to be multiplied by an x minus 2, top and bottom. If you write this in a different order than I did, same in the last one, it's okay. You'll still get the same answer, okay? And then the second one is going to need to be multiplied top and bottom by an x plus 3. So when I go on to my next step, we have a times x minus 2 plus b times x plus 3. And that's going to be equal to the original question's numerator, right? My new numerator equal to the old one so that I can solve. All right. Same next step. I want to try and cancel out one letter at a time. Let's cancel out a first. I can cancel out a if x is 2. So if x is 2, then I have a times 2 minus 2, which is going to cancel, plus b times 2, remember plugging the 2 in there, plus 3 equals 2. And I also need to plug the 2 in. Now I have an x on the right side. Okay, so now 2 plus 3 is 5, so I have a 5b equals 2 times 2 is 4, plus 11, I have 15. If I divide by 5, that means that b equals 3. Okay, we're going to do another if so that we can cancel out the b. So if b were a negative 3, then negative 3 and positive 3 would cancel out the b. Let's fill that in. Okay, so now negative 3 and negative 2 make a negative 5. This cancels. Negative 3 times 2 is going to be negative 6 plus 11. We have 5. Divide that negative 5. We have that a is negative 1. Okay, now that I've solved for my a and b, I'm going to plug them back in and I'm going to solve this integral. So I'm going to draw a line here. The integral, a we said was negative 1. I can put the negative on the outside. Plus the integral, the next one, b we said was a positive 3. Okay, so since 3 is just a coefficient, just like I brought out that negative, I can bring out that 3. You are always allowed to bring coefficients to the front. Okay, and now, believe it or not, we have the same exact ln rules going on as the last time. So if u here is x plus 3, my u prime is just 1. So I could say negative integral of u prime over u plus 3 times the integral. Here my u is x minus 2. Always make sure you double check this u sub. Okay, it's good. Now I can say u prime over u. So I have negative ln of absolute value of u, and here my u is x plus 3, plus 3 ln absolute value of u, in this case my u is x minus 2. Okay? Here is one option for your final answer. So I still have that subtraction rule going on, just so that we refresh those ln rules. Another option is that coefficients can go up as exponents, okay? So I could say negative ln absolute value of x plus 3 plus ln absolute value of x minus 2, and this would be cubed. And of course, the last option is the division, where the positive value goes in the numerator, the negative goes in the denominator, and it's written as one single ln. Positive in the numerator, the negative ln goes in the denominator. Three different options for this one. If you are working on a free response question, you can stop on the first one. You do not need to write any of these alternatives. This is just in case it's a multiple choice and they have you match them. Granted, these questions don't typically come out in the FRQs though, okay? These next questions are going to start to get a little more complicated. Let's take a look at this one. My denominator looks like it's already factored out for me, but there is something else that I can factor out, okay? Notice here there's an x in both terms, so I can say x times x minus 1, and then here nothing can get factored out. It's just an x squared plus 4. If it was an x squared minus 4, then I can factor an x plus 2 and an x minus 2, but this is a plus, so be careful, okay? So now this integral is going to be a over x plus b over the x minus 1. And then plus, notice here there's a squared. We talked in the beginning with our notes that whenever it's a squared, there has to be 1 degree less in the numerator. So I have to put cx and then plus d. Okay. So we've split it, we factored. Next step is to multiply by the common denominator. Now, this one has 3 fractions and it's a little messier. So I'm going to come down here. For the first one, a, if we need a common denominator, it's missing the x minus 1 and the x squared plus 4, okay? Now it's going to look really messy, but believe it or not, we're going to be able to start cleaning this really nicely, okay? So next one is b. Now this one has the x minus 1, but it's missing the x and the x squared plus 4. Do not distribute that, okay guys? And then the last one is missing the x and the x minus 1. Again, it looks messy, but bear with me. We're really just paying attention to this numerator right now, okay? So I'm going to write out just the numerator and then set it equal to the original's numerator, okay? So I wrote out that whole numerator, just rewrote this, and now I'm going to set it equal to the original numerator. All right, so now it's time to use algebraic methods to start solving for A, B, C, and D, okay? Your next question is to start plugging in the ifs. If x is blank, what can I cancel out? Right now, just by looking at this, x being equal to 0 will cancel out all of these, and I can solve for A. X being equal to 1 would cancel out these two, and I can solve for B. Okay, solving for C and D is going to be a little more complicated, but those are going to be our two easiest, okay? Let's go ahead and move on to those. Here, I can't really cancel out. Notice I didn't mention this one because no matter what I plug here, it's going to get squared and then be added by a 4. So I can't really cancel there. Let's start with the first two ifs that I mentioned. If x is 0, okay? Now, if you want to get a little faster at this, if you notice it's going to cancel out a whole term, you don't technically have to write it, okay? I am going to write it for the sake of the video, for those of you that need to see it. The moment I do notice that it cancels something out, I do like to cross it out. I just noticed I should be writing a bracket here because all of this is getting multiplied by all of that. But because that 0 is there, this one's going to get canceled. All right, so let's talk about what I have left. This is A times -1 times 4. So I have a -4A. All of this got canceled, all of this, this, and this got canceled, and I'm left with a -8 on the right side of my equation, okay? If I divide over that -4, I can say that A equals 2, okay? Now, the next one we talked about being nice and easy is x being a +1, because then all of this and all of this gets canceled out, okay? So this was our first one. Let's go on to the next one. If x is +1, okay? So rewrite all of this. I know it's lengthy, but hopefully it doesn't feel difficult. Okay, this one's going to cancel out. I like to cancel out at the beginning so I don't forget it. This one doesn't. Oh, notice that I put an x here by accident instead of a 0. That was a little mistake on my end. That should be a 0. Okay, because it does have an x. Okay, and because of this, this whole thing is going to get canceled, okay? All right, so we do have one term left here on the left and one term on the right. So we can solve for B. Little lengthy, but no big deal. B times 1 is B. This is 1 squared plus 4 is 5. So I'm going to get a 5B equals 1 cubed is 1 times 2 is 2. 2 minus 4 and then minus 8. I end up with a -10. Divide over that 5 and I get that B equals -2. Okay? So now we had mentioned that the 0 and the 1 is going to easily cancel out, but not for this number. So now what I want to do is rewrite this statement, plugging in my A and my B. Remember I told you the moment you know some of the answers, you can plug those in, okay? Now I'm going to plug in the A and the B, but I also have to plug something in for X. Use the easiest number you can think of. We already did 0 and 1. If you like 0 and 1, you can go for that as well, okay? I'm going to use a different one just so that you see how it still works. So if X equals -1, A is 2, and B is -2, okay? I'm going to go ahead and fill those out. Look at me, I already put the A. Sorry about that. So for A, we said it was 2. I put the X as -1. And now moving on to the next term, plus B is a -2. We said X is going to be a -1. We don't know C, and we don't know D, okay? So we have X is -1 plus D. And then we said X is going to be -1. All right, okay? So here, let's start cleaning everything we can. I have 2 times -2 times 5 plus -2 times -1 times 5 plus a -C plus D times a -1 times a -2 equals, and then when we clean this side up, we end up with a -6. When I start to clean this, here I get -20 plus 10 minus 2C plus 2D equals -6, okay? -20 and +10 make a -10. I add that over to the -6 and I get a 4. So I get -2C plus 2D equals 4. I can factor out a 2 and divide it over, and I'll get -C plus D equals 2. Now, I was not able to isolate one variable, but I was able to isolate 2. If I do that again with a different X, I'll come up with 2 equations with C and D, and then I can do a system of equations, okay? So for my next equation, I'm going to pick another X. I'm going to say if X is 2, we already knew that A was 2, and that B is -2. I'm going to go ahead and plug that in. All right, so all I did here was plug in a 2 in every X, a 2 in every A, and a -2 in every B. When I start to clean this, I get 2 times 1 times 8 plus -2 times 2 times 8 plus 2C plus D times 2 times 1. And if we clean up this right side, it gives me 0. I end up with 16 minus 32 plus 4c plus 2d equals 0. 16 minus 32 is a negative 16. If I move that over to the right side, it's a positive 16. And then I'm going to divide out a 2 and end up with 2c plus d equals 8. Okay, so now I have my second equation. Okay, so now what I'm going to do is I'm going to grab the one that I had gone first, that negative c plus d. Negative c plus d equals 2. And this one as well, 2c plus d equals 8. Now, if we remember from Algebra 2's system of equations, I want to try and cancel one of those out. So notice I have two positive d's here. If I multiply one of them by negative 1, I'm going to be able to cancel them out. I'm going to rewrite the second one. And now I can combine them. I'll eliminate d, and I have 3c equals 6. Divide that 3, and I have that c equals 2. Now I'm going to go ahead and plug that c into the first equation I found. It was nice and easy right here, the negative c plus d equals 2. And instead of the c, I'm going to replace it with that 2. Okay, move that over, and I get that d equals 4. Now that I know all 4 of my variables, I can go ahead and plug that back in. And I can say the integral, if my first one was a over x, and my a is 2, I'm going to put 2 over x plus, the next one is, b was a negative 2 over x minus 1, plus I had cx plus d. If c is 2, x plus d is 4 over, I had x squared plus 4 dx. Okay, so I'm just going to start cleaning this a little bit. This right here can be split up to say 2x over x squared plus 4 plus 4 over x squared plus 4. That's just this term. Remember, whenever I have two things being added or subtracted in the numerator, I can write them as two separate fractions. Okay, so now I'm also going to put the coefficients up front. I'm going to say the integral of 2 times the integral of 1 over x dx. I'm going to bring the negative 2 to the front. Integral of 1 over x minus 1. Now for this one, if you're catching the u sub, I encourage you not to move the 2 to the front, because I'm going to get a 2x here anyways. So, oops, I got to put my dx plus the integral of 2x over x squared plus 4. Now here, I'm going to go ahead and move that 4, because if I did u sub, this would be a 2x as well. Times the integral of 1 over x squared plus 4 dx. So if I remember my u subs, you can start getting a little faster at this. I'm going to come down right in here. I have 2. The antiderivative of 1 over x is just ln absolute value of x. I'm going to write my plus c all the way at the end. I have minus 2. If this is my u prime is 1, so I'm good. So the integral is going to be minus ln absolute value of u is x minus 1. Now I have plus, if this is u, then my u prime is 2x, so I'm also good here. My integral is going to be the ln absolute value of u is x squared plus 4, plus 4, and I have 1 over x squared plus 4 is an arctan, okay? If we remember our arctan rules, So in an arctan, we're looking for who our u is and who our a is. So if u squared is x squared and a squared is 4, that makes my u x and my a 2. If you don't remember that, go back to chapter 5. So I have 1 over a, so it's 1 over 2 times arctan of u over a, which is x over 2 plus c. Okay? Our last step now is just to clean this 4 and this 2. So I'm going to rewrite this, and then 4 divided by 2 would just be 2. So if you see this in a multiple choice, it'll look something like this. And that would be our final answer right there. A little lengthy. For our last example, I'm going to show you the scenario when we do have an exponent outside of the factor. So if I look at this inside, x squared plus 2, I can't clean anything out of there, but there are 2 of them. Okay, so that's the scenario where I told you we're going to have to write them first to the first power, and then to the second power. Okay? So now, being that this has an x squared, this is going to be ax plus b, and this one also has a squared on the inside. This one has both scenarios. This is going to be cx plus d. All right? Last, probably most complicated scenario. Next step is to multiply the other, or multiply each by common denominator. My common denominator is having 2 of these, right? This one already has 2 of these, so I'm not going to have to multiply anything here. I'm only going to have to multiply an extra one to this one, okay? So it's going to look something like this. So now I'm going to multiply just the numerator, and I have ax plus b times x squared plus 2 plus cx plus d equals, remember my original numerator, ax cubed plus 13x. Now, in this example, I'm going to show you an algebraic method to clean this that's probably one you haven't seen in a while. The first thing I'm going to do is I'm going to FOIL this over here, okay? And then, being that I have exponents going higher than squared, I'm going to start trying to match my exponents on one side with the other. So let me start off by FOILing. So notice that I have a cubed, a squared, I have to the first power, and then I have constants, okay? Since I go from cubed all the way down to constants, I'm going to fill out what would be the squared here and what would be the constant here. So I have an 8x cubed. Since I don't have any x squareds, I'm going to say plus 0 x squared. Bear with me for a minute. X to the first, I have 13 of them. And then constants, I have 0, okay? I want to now group on my left side the cubes, the squares, the x to the first, and then the constants. So cubed, I only have one of them. I have ax cubed, okay? Squareds, only one of them. Now, x to the first power, I have 1 over here and 1 over here. So I'm going to say plus, if I factor out the x, right, I factor out the x, I have a 2a plus cx, right? And then now same thing for constants. I have 2b plus d, okay? So we'll say and I'm just going to rewrite this side here. So now we have this rule that we are allowed to compare the exponents that are equivalent. So take a look. If I compare my cubes, ax cubed should be equivalent to 8x cubed, okay? Which means that if I cancel out the x cubes, a should be 8. I have my first answer. Let's do the same thing with the x squared. I have bx squared and 0x squared. If I cancel out the x squares, that means that b should be 0. Okay? Now for this next one, I have 2a plus cx should equal 13x. So I can say, cancel out the x's. I should say that 2a plus c should equal 13. I'm canceling out the variable. Now I know what a is. So I can say 2 times 8 plus c equals 13. Okay? 2 times 8 is 16. Move that over, and I get that c is -3. All right? And last one, let's look at the constants. My constant here, 2b plus d, should be equal to my constant here, 0. So now I have 2b plus d equals 0. I know what b is. So I should say 2 times 0 plus d equals 0. So d equals 0. Next step is to plug in a, b, c, and d back into the expanded version of my integral. So I have the integral of a is 8x plus b is 0 plus the integral of cx. C is -3x plus d is 0 over that denominator. All right, so now obviously the 0 I don't have to worry about. I'm going to take out my coefficients of 8 and 3. So I have 8 times the integral of x over x squared plus 2. Take out the -3 times the integral of x over x squared plus 2 squared. Now, anytime my denominator is to the first power, I'm going to do a u sub here. Actually, I can do a u sub for both. I'm going to tell you what I was talking about there in just a minute. If my u is x squared plus 2, my u prime is going to be 2x. Okay, so for this one and this one, I'm missing, this is the same u for both, okay, a 2. So I need to put a 2 and a 1/2, a 2 and a 1/2, okay? This one is going to be rewritten, let me scroll a little bit here, as 4 times the integral of u prime over u minus 3 over 2 times the integral of u prime over, be careful because here my u is just the inside, I have u squared. Okay, this one is an ln rule, right? 4 ln absolute value of u minus 3 over 2. I'm going to rewrite this as u to the -2nd, and instead of u prime, I'm going to put du. So anytime it's to the first power, it's an ln rule. Anytime it's any other number, I want to bring it up and change the sign of that exponent, okay? So now, here my antiderivative, okay? I'm going to add 1 to the exponent, u to the -1st, divide by that new exponent of -1, so it just becomes a positive 3 over 2 I'm gonna write my plus c, bring this down. And now let's fill in our u's. Our u happen to be the same for both. So I have 4 ln absolute value of x squared plus 2. Because x squared will always be positive and adding a 2 will always be positive, don't be surprised if you see parentheses instead of absolute values, like on a multiple choice. Plus 3 over 2. U is x squared plus 2, but u to the negative first means 1 over that u. And then plus c. And you are done with this question.